So in this video we're going to be using Riemann sums to calculate the area under this graph, which is 7 minus x. Using Riemann sums, technically we could use the area of a triangle, which is equal to 1/2 base times height. We could get it that way, but we could use it. But we'll be doing it the long and hard way using Riemann sums. So what equation we're going to use is R of n is equal to delta x times the summation of n. J is equal to 1 of f of a plus j times delta x. And we know that delta x is equal to b minus a all over n. So 5 minus 3 all over 8 is equal to 2 over 8, or 1/4. So R of 8 is equal to 1/4. Well, let's just write this a little more down to give ourselves more room. But since we already got the equation, we could just erase it all. You know that delta x is equal to 1/4. So that should just lead us on the right path, pretty much. Let's just erase all this just to give ourselves, because these problems are usually really long and have lots of, algebra and just arithmetic, and that's usually where people get themselves, in trouble, pretty much. So we're just going to write all this up here, because this is going to be pretty long. So we know that R of n is equal to delta x times the summation of j is equal to 1 of f of a plus j times delta x. So we're going to say R of 8 is equal to 1/4. We just calculated delta x. And we know n is equal to 8 times the summation j is equal to 1 of f of a, and we know a is 3 plus j times delta x, which is 1/4. So we're going to go R of 8 is equal to 1/4 times the summation 8, j is equal to 1, let's make that look like a j, f of 3 plus j over 4. So we're going to go R of 8 is equal to 1/4 times the summation of 8, j is equal to 1 of f. So let's just get common denominators here. So 12 over 4 plus j. Let's just make that look correct. And so that's pretty much just as far as we can go for now. So let's just write this out one more time. So what we're going to do with this Riemann sum, so the idea is this j, we're going to start at 1 and go all the way up to 8. And then that's going to give us all, and we're going to do that 8 different times, which is R of 8 means. And it's going to give us the area under the graph, and we're just pretty much just going to break the area of this into 8 separate triangles and calculate the area of all of them. And that's what the summation, we're just adding the sum of all these triangles area up and calculating the area. So we got this now. So I'm going to have to erase all this up top to start over again. And it's going to be a long sequence of adding each rectangle up, because we're going to have to plug the function in for here. So it's going to be r of 8 is equal to 1/4 times 1/4 times 7 minus x, and this is x, 12 plus 1 all over 4 plus 7 minus 12 plus 2 over 4 plus 7 minus 12 plus 3 over 4 plus 7 minus 12 plus 4 over 4, go down here, plus 7 minus 12 plus 5 over 4 plus 7 minus 12 plus 6 over 4 plus 7 minus 12 plus 7 over 4 plus 7 minus 12 plus 8 over 4. We started at 1 because j is equal to 1, and we went all the way up to 8. So that should be correct. Just make sure I got everything right here. So f of x is equal to 7 minus x. Interval 3 to 5. And so, r of 8 is equal to 1/4 times 7 minus 13 over 4 plus 7 minus 14 over 4 plus 7 minus 15 over 4 plus 7 minus 16 over 4 plus 7 minus 17 over 4 plus 7 minus 18 over 4. Let's start over here. Plus 7 minus 19 over 4 plus 7 minus 20 over 4. And we can add parentheses around all our fractions. Let's move that out the way. So now we're just going to get common denominators with everything, pretty much, with all this stuff. The 7 minuses. So r of 8 is equal to 1/4 times 28 minus 13 over 4. 28 over 4 minus 13 over 4. We'll put parentheses and make this look uniform. Plus 28 over 4 minus 14 over 4. Plus 28 over 4 minus 15 over 4. Plus 28 over 4 plus 16 over 4 minus 16 over 4. They said arithmetic is usually where people get things wrong. Minus 28 plus 28 over 4 minus 17 over 4 plus 28 over 4 minus 18 over 4 plus 28 over 4 minus 19 over 4 plus 28 over 4 minus 20 over 4. So as you can see, it's pretty long, so let's just erase this up here. To give ourselves some room, because these problems are extremely long, and they don't go away throughout calculus. You usually see summations and series and stuff, which is in Calc 2, which is pretty long. Nothing like this though. I mean, at the beginning of Calc 2 you do get stuff like Simpson rule and all that. But you have to calculate stuff. Calculate things exactly like this, just with different formulas. So 1/4 times, let's see, it's 15 over 4. It's 10, yeah. It's 10 over 4 plus 9 over 4. Hold on, no, that isn't right. 15 over 4 plus 14 over 4 plus 13 over 4 plus 12 over 4 plus 11 over 4 plus 10 over 4 plus 9 over 4 plus 8 over 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're almost done with this. So let's just add this on our calculator. Just to make sure we don't have any error. 15 plus 13 plus 11 plus 10 plus 9 plus 8. This is going to equal 92 over 4. And then 92 over 4 is going to equal, so R of 8 is equal to 1/4 times 23, and then R of 8 is equal to 5.75. And that should be your final answer after summing up all the triangles on the graph. That looks like this. From interval 3 to 5. Or 5 is not quite right there, but that's 7, because that's where it crosses the x-axis. So interval 3 to 5. That is not the exact area. This is just an approximation, pretty much. Because there is some error that goes into Riemann sums, and they're really not that good at calculating area, to be honest with you, compared to like the fundamental theorem of calculus, and Simpson's rule is really good when it comes to that, because it uses trapezoids more often, so it becomes even more accurate. But for Riemann sums, and for now, this is just going to be the simple process of finding the right and the area of the triangles, area under this curve, using Riemann sums.